let's see how the ideas of discretization and linearization are put together into an algorithm for the iterative solution of our boundary value problem. Going back to a channel flow example with the discretization we were looking at, the division into the cells, we start by assigning guess values at the cell centers. So we would assign guess values for velocity and pressure at each of these cell centers. And we would tweak these guess values or correct these guess values using the linearized algebraic equations. And that's where the discretization would come in. And so we would go to each cell and we would tweak those guess values and say if I'm tweaking the guess values for that cell, it would involve the values at the neighboring cells. And that is, that's going to have, so my current solution after I tweaked it will have a linearization error in it. And so I need to know what the level of the linearization error is. And I assess that by calculating the aggregate mass and momentum imbalances, like we talked about. And then we check if the aggregate mass and momentum imbalances are less than a tolerance that we specify. And if those imbalances are greater than a tolerance, that means our linearization error is too large, it's not acceptable. And what we have to do is we have to go back and recorrect or retweak these guess values and recheck, if the linearization error has gone down. And if this process converges after some number of iterations, your imbalances for each, for mass, x momentum, y momentum is going to fall below the specified tolerances, and we have the converged solution, which means that now our linearization error is below a specified tolerance level, and we have a good enough solution to a nonlinear set of algebraic equations, i.e. we have an approximate solution to a boundary value problem, and this approximate solution, the linearization error is below a tolerance, and there is a discretization error, so we have to see the effect of the discretization error by refining the mesh and using more cells.